Okay, laws of limits. If you have two functions are being added together, for example, suppose you have the limit as x is going to 1 of x squared plus 3x. Okay? What you could do is you could say, well, that's going to be the same as the limit as x approaches 1 of x squared plus the limit as x approaches 1 of 3x. Okay? So you can say the limit as x approaches 1 of x squared is 1. The limit is x approaches 1 of 3x is 3. So together it's going to be 4. So if you have two that are added together, you can separate it as limit as x goes to a of f of x plus the limit as x goes to a of g of x. Now it's going to follow suit for subtraction, multiplication, division. Just want to, if you do have a constant, you could write that as the constant of the limit as x goes to a of f of x. So you can always pull that constant out front if you would like. Right. What I really want to spend time looking at is example number 7, example number 8. The limit as x approaches a of a constant. So, for example, suppose I have the limit as x approaches 2 of 5. What does the function 5 look like? 1, 2, 3, 4, 5. It is a horizontal line. Does everybody agree? So if I look as x approaches 2, what is the height approaching? Would everybody agree that the limit of a constant is just always the constant? Very good. Limit as x approaches a of x. So now what does the graph of x look like? Something like that. So if I plug in an x value of 2, I get out an x value of 2. If I plug in an x value of 3, I get out an x value of so on and so forth, right? Okay. So the limit as x approaches a of x, would that be a? Whatever value you're approaching, that's what you're getting out. If you have a polynomial of higher degree, say x to the nth, it's just going to be a to the n. You can just plug it in. Here you would have the nth root of a, which is equal to a to the 1/nth power. That's how we type that in, if anybody's forgotten. This would be f of a to the 1/nth power. So, direct substitution for a polynomial or rational function. You have a polynomial or rational function, limit as x approaches a of the function is simply just f of a. Many times we can take functions and simply substitute value in to determine what the limit is. It's because these are nice behaving functions. Let's look at some of the rules, and then we'll get to some of the algebra here in a second. Given that the limit as x goes to a of f of x is 6, limit as x goes to a of g of x is -2, and limit as x goes to a of h of x is 0, determine what the limit is. If it doesn't apply or it doesn't exist, let me know why. So limit as x goes to a of f of x plus g of x. Anybody want to guess what that would be? It is 4, because this is the limit as x goes to a of f of x plus the limit as x goes to a of g of x. And you know that this first part is 6, and the second part is -2. That makes a grand total of 4. I'm going to switch this one, rewrite as limit as x goes to a of h of x divided by f of x. Anybody want to guess what that would be? Yep, 0 divided by 6 gives me 0. Again, you could break this into a couple parts, but it's really not that big of a deal. What is the limit as x goes to a of g of x? Negative 2. So we end up with negative 3 times negative 2 plus 5, or rather 11. Do the last one on your own. All good? Any questions there? Flip it over. This is the graph of f. This is the graph of g. The limit is x approaches 1 of f of x times g of x. I'm first going to find f of x and then g of x. Limit as x approaches 1 of f of x. As x approaches 1, what's the limit? 3. G of x, negative 1. Now I'm going to approach 0. Approximate the value if you can't determine it for sure. What do we have for f? Sure, 2 times 2.5 minus 3 times negative 2. Limit as x approaches 2. Now we look at g of x first. As I approach from the left, I have 0. As I approach from the right, do you know what this is trying to show? The bar graph behavior. So it's not, some people say, well, I'm going to just choose the middle and say it's 4. The limit from the left is 0. The limit from the right does not exist. So therefore, the limit as a whole does not exist. And when you're doing computation, if any part does not exist, then the entire limit as a whole does not exist. See if you can figure out D on your own. Go. We good? Okay, so you've seen a graphical method. You've seen kind of that abstract way of approaching them with the laws. Now let's look at some algebraic methods. The first question is, kind of, do you know what the function looks like? You know what a quartic looks like, right? Something like that, right? And so it's got nice behavior all the way across. It doesn't have any asymptotes or anything like that. You can simply just plug in 1 and evaluate that limit. And so we get 1 minus 3 plus 1. So negative 2 plus 1 is going to be negative 1. That's the limit. You know what the cubed root function looks like? It looks something like this. Okay, this one will be shifted to the right 27 units. Nice behavior all the way across. You can just plug in 0, right? And so when you do, you get the cubed root of negative 27, which is negative 3. Sometimes you have a function that you don't necessarily know what it looks like, but you realize when you plug in 3, we get 0 over 0. So everybody see that? When you get 0 over 0, that's a problem. What that means is the graph looks something like this. It has a gap that exists. We want to try to find where that gap occurs. All we need to do is remove that, what we call that discontinuity. We need to remove that spot where you get 0 over 0. And if we just factor the top, x minus 3 over x plus 3, divided by x minus 3, you can see that the x minus 3's cancel. So now I can simply do the limit as x goes to 3 of x plus 3. And what do I get? 6. Try the next one on your own. Negative 5? Very good. Flip it over. Again, I tried plugging in 0. If you plug in 0, what do you get? I get 0 over 0. Anybody have a thought how I would handle this? Come on, try something, try anything. Take this and do what with it? Multiply it out, square it. Very good. So we would get h squared minus 4h plus 4 minus 4 divided by h. What happens to the 4's? They cancel. Now what can I do? Can I get the limit as h goes to 0 of, when I factor out that h on top, it will cancel with the 1 on the bottom. I have h minus 4. Can you now plug in the 0? And what do I get? I think that'll be a good idea for f, but how is f different? It's cubed. But fortunately, you remember the binomial theorem, right? Pascal's triangle. So you all remember that this is going to multiply out to an h cubed and an h squared and an h and an h to the 0. And then you're going to have a 1, so on and so forth. And then these are your coefficients. So 1, 3, 3, and 1. If you don't know that or can't do it, then you just have to take h minus or h plus 1 times h plus 1 times h plus 1, which isn't that bad. It'll take a little bit of time. Divided by h. Isn't that nice that the 1's cancel? They sure do. The 1's are gone. I take an h out of there. I'm left with the limit as h goes to 0 of h squared plus 3h plus 3. When you plug in the 0, what do we get? We get 3. Always try to plug in your x value first, You plug in 1, and what do you get? 0 over 0. That's a problem. We need to determine what 0 over 0 is. Any thoughts? So the C conjugate. When you don't know how to do the math, do the Spanish, right? You could multiply by the conjugate. I have an even easier way to do it. Would you like to see an easier way? Suppose that this was 1 minus x squared. You would say that that factors, correct? To the difference of two squares, 1 minus x and 1 plus x. Agreed? Well, I'm going to argue it still factors. 1 and 1. What do you multiply by itself to get x? Square root of x. Can I now plug in the 1? What do you get? 2. Plug in the 0. What do you get? That's a problem, isn't it? Yep, that's a big problem. So, I'm going to take Ishika's advice. I'm going to multiply by the conjugate. I don't see really any way around this. What is the conjugate here? Square root of h plus 9 plus 3. Remember, conjugate means to change the ending, right? So we change the ending. Please be careful with the fraction you've set up now. I'm going to make sure I write this out. Limit as h goes to 0 of square root of h plus 9 times square root of h plus 9. H plus 9. What's going to happen to the middles? Cancel. Negative 3 times positive 3. And then in the denominator, we have h times square root of h plus 9 plus 3. What's going to happen? 9s are gone, and h cancel. What do you have in the numerator then? A 1. So I try plugging in 0 now, and I get 1 over 6. Now, as you look at letter I, you might be inclined to try to see if something would cancel. And if you do find common denominators here, like multiply the top and bottom by 16 here, and top and bottom by x here, you're going to see that something nice does happen. We get the limit as x goes to 0 of, in the top you have 16 minus x squared. What's the denominator? What's your new denominator now? 16x over, so we have a complex fraction. Now a fraction over fraction, what do we do? Yep, limit as x goes to 0 of, I'm going to write this as 4 minus x times 4 plus x over that 16x times 1 over x minus 4. Can I cancel off the 4 minus x and the x minus 4? What do I have to factor out first? So I'll put the negative there, cancel these 2 off. So great, we got rid of the x minus 4. Let's try to plug in the 0. As you plug in the 0, what do I get? I get 0 plus 4, which is 4, times negative 1, which is negative 4, over 0. So this is an example where you cannot actually simplify or solve this one algebraically. You really have to look at the graph, or you have to look at a table. So take out your calculator so we can see what happens there. Because I want to be clear, you might be inclined to say, well, Mr. Gens, I believe that it does not exist, or I believe that it's undefined. You can't really make that statement yet. You can't. We must look further. Got to get that. Sam with the gun. That was a good time. Good memories right there. All right, so in the numerator, I have a -4 minus x. And in the denominator, I have a 16x. Realize every time you put something in the denominator, you need to put parentheses around that. So everybody agree that this is my function. So I'm going to zoom 6 into a standard viewing window. Hard to see what's going on, isn't it? Should we zoom in? Zoom as a box. So if I'm going to determine the limit, I have to both consider from the left as well as the right. What's the limit from the left? What's the limit from the right? Are those the same? So by looking at the graph, we can now confirm that this, in fact, does not exist. Maddie, I swear you have a question. No? You're positive? All right. If you would check out the table, that would be another method. I can approach 0 from the left. What are some values that can approach 0 from the left? -1, -0.1, -0.01, -0.001. Would you agree that those are getting significantly larger? You approach 0 from the right, 1, 0.1, 0.01, 0.001. You can see that those values are getting significantly larger, but they're negative. So this confirms your thought. The last one, limit is x goes to -5 of the absolute value of x plus 5 over x plus 5. If you plug in -5, what do you get? 0 over 0. Again, there's no way for us to really simplify that absolute value. If you were to check the graph, your absolute value is located in your math section under numbers. Absolute value of x plus 5 divided by parentheses x plus 5. I'm going to zoom standard so I can get my graph. Zoom 6. And you notice that you get this graph. Again, we must be smarter than the graph. If we're not smarter than the graph, then smarter than a calculator, then we're in big trouble. Here's what that graph looks like. So as I approach as I approach -5 from the left, what's the limit? -1. As I approach -5 from the right, what's the limit? +1. Are those the same? So therefore, it does not exist. Good work, folks. We pick up with piecewise function limits tomorrow.